Hello guys, my name is Vinay. I am from IT Delhi. Today we are going to cover the topic of calculus, that is Cauchy Condensation Test, which is a very important topic. Now calculus is the basic requirement for every subject you need to know. So in this video we are going to cover the topic Cauchy Condensation Test, which is used to check the convergence or divergence of the basically convergence of the sequences, positive number sequences. So let's start. So let's see what does Cauchy Condensation Test says. According to Cauchy Condensation Test, this sequence an 1 to infinity is a decreasing sequence of it is a decreasing sequence of positive numbers, then summation of n equal to 1 to infinity an converges if and only if summation of n equal to 1 to infinity 2 to the power a to the power 2 converges. So these are equivalent, like if this converge then this will converge, if this converge then this will converge. This is the meaning of if and only if. Now let's see its proof. Consider one more important point. Here we have assumed that this is a decreasing sequence and this is an decreasing sequence of positive number. That is an is greater than or equal to an plus 1 and an is greater than or equal to 0. Now consider two sequences Sn k equal to 1 to n an take and tn k equal to 0 to n a times 2 to the power k. Okay. Consider two sequences. Okay. Now Sn is equal to a1 plus a2 plus a3 plus a4 plus a5 plus a6 plus a7 up to a to the a. Okay. S of 2. Okay. So can I write it like that? A1 by 2 plus R4 a1 2a2 plus that it is greater than or equal to 4a4 plus 8a8 2 to the power a of 2 to the power. Can I say that? यू मे वंडर हाउ मैंने ये कैसे लिखा. मैंने क्या किया, इन दोनों टर्म्स को क्लब किया, फिर यहाँ से लेके ए तक की ये टर्म्स को क्लब किया. सो ये 2a4 से बड़ा होगा, ये 4 और 8 से बड़ा होगा. क्यों? क्योंकि ये डिक्रीजिंग सीक्वेंस है ए एन हमारा. तो ये जो सी भी हमारी चार टर्म्स है इनमें से सबसे छोटी टर्म है ए. तो मैं इन सभी टर्म को अगर मैं 8 से रिप्लेस कर दूं तो जो हमारा सम आएगा वो 8 से तो बड़ा होगा. तो ये लिखता गया, मैंने इनको 2 से डिवाइड किया, इंटू 2 कर दिया, तो जो हमारा सीक्वेंस है वो ये बने. सो दिस इज इक्वल ग्रेटर देन a1 by 2 plus tn by 2. Now we have s of 2n a1 by 2 plus tn by 2. So according to this, if t to the power n converges, if Sn converges, implies s of 2n converges, implies tn converges. Okay, so we have done this. Like how using comparison test we can say that if this converges then this will converge. Okay, so we have proved the part this one. We have proved this part, that Sn converge implies s of tn converge. We have proved this part. Now let's go to the backward part. Now we have to prove tn converges implies s Sn converges. Now we have to prove this. Now, now let's write s of 2 and 1 minus 1. This is equal to a1 plus a2 plus a3 plus a4 plus a5 up to a2 and minus. This will a1 a2 plus a3 a4 a7 plus a2 and minus 1 minus 1. Okay, so this is less than a1 plus 2a2 plus 4a4 to the power n minus 1 times. Since it is an decreasing sequence, so I can say that a2 plus a3 is less than 2a2. Similarly, other terms. So this whole terms will be like, so this is our tn minus 1. So I can say that as a 2 minus 1. No, and this is less than equal to s of n. Okay, so if Tn converges, then T of n minus 1 converges. If T of n minus 1 converges, this implies S of 2n minus 1 converges. 2 of 2 to the power n minus 1 converges using comparison test. And using comparison test, we can also get S of n converges. This implies Tn converge implies Sn converge. So we have proved both forward and backward part. That if Sn converge, then Tn converge. If Tn converge, then Sn converge. Now let's see an example how to use to prove the convergence of a sequence or to find the convergence of a sequence. Now this is an example. You have to find the values of p for which the series 1 upon n to the power p converges. N equal to 1 to infinity to the n to the power p converges. So let's p is greater than 0. So an is equal to 1 upon n to the power p. So can I say that an is always greater than 0? Since n is a natural number and anything to the power of a natural number is positive. So 1 upon positive is positive. So an is always greater than 0. So an minus an is, can I also say this, as n is less than n to the power p is less than n plus 1 to the power p. Can I say that? So 1 upon n to the power p is greater than 1 upon n plus 1 to the power p. So this is an, this is an plus 1. So an is a sequence of positive numbers with decreasing nature. So I can apply Cauchy condensation test. So what is, so let's write it there. It will be equal to 2 to the power n into 1 upon 2 to the power n p minus 1 and equal to 1 to infinity. This is equal to 2 to the power n p minus 1. Now there we have three cases. If p is greater than 1, then 1 upon 2 to the power n into p minus 1. Summation of this converges because this is basically a GP and with common ratio less than 1. We know that now if 1 plus r square to the power n, this converges to 1 upon 1 minus r if r less than 1. So similarly we can say that here common ratio is less than 1 as common ratio is 2, 1 by 2. So we can say that this series converges if p is greater than 1. Now say let's say p is less than 1. So this will come 2 to the power n 1 minus p. Here common ratio is greater than 1. So this GP diverges. So our conclusion is 1 upon n to the power p converges. Summation of this converges if p greater than 1, diverges. Okay. So this sequence diverges for p less than 1 and converges for p greater than 1. So we have to find the value of p for which it converges. So for p greater than 1, this series converges. Thanks for watching.